Hi everybody, welcome to 1.2 linear measure. I think that we might have two parts for this video, but the second one will just be examples for the most part. We already started talking about this a little bit in class, but we talked about between and betweenness of points and how to actually define something like that. And what we came up with, or what we figured out, is that the way mathematicians decided to define it is this. Point I is considered to be, considered between point H and point J, since the 3 points are collinear and Hj must be equal to Hi plus Ij. Hi plus Ij has to equal the total. And it's just kind of a weird looping around itself kind of definition, maybe you think. But what I need you to super duper remember is collinear, and then that the whole is equal to the sum of the two parts. So what we're going to be doing for this section is we're going to be using this information, especially this equation here, and we are going to use this definition to find measures of segments based on other measures that we already have, okay? So, for example, if I had a line like this, now I put arrows on the end, but that's okay, because I'm going to be talking about the segments here. So the fact that it continues on afterwards is not an issue for me. I'm going to be told that this is 3.2 inches right there, and then BC is 2.0 inches. And then the instructions for a problem like this are going to say find the measure of AC. Okay. Now, we know that we're probably dealing with some betweenness of points because we're in that section, okay? When you have something like this on the test, you can kind of think about, okay, well, I see that B is between A and C on the line, so I can use the equation of AC equals AB plus BC. I can use that because of the betweenness. And then I plug in what I know, just like we do in algebra. Plug in what I know, simplify, and I find that AC is equal to 5.2 inches. Please put your units. 5.2 inches is your answer. So not too bad, right? Let's look at another one. You might also have something like this. All right, this one doesn't label our points, but we can see that that point right there is between the two endpoints. And so if I add up those two segments, I should be able to figure out what the whole segment length is. So the way that I'm going to do this one is 1 centimeter. This is kind of not what I want to deal with really. So 1 centimeter, I'm going to call that 16 over 16, okay? And then that's going to make my life a lot easier when I am adding together these two. I'm going to say, okay, well, that's 46 over 16. And I need to simplify that because those are both even numbers to get my official answer, 23 over 8. So 23 over 8 centimeters is the official length of that segment. I don't know, that doesn't seem super useful, I know, but it's possible, and that's why we look at it and we're able to just go along with it. If you have like a real world example, you are probably not going to have something like 23 over 8 centimeters as your answer. So let's look at, we'll do a try problem. So try problems. If you are new to having me as a teacher, oh, sorry, this needs to say try. Try problems are where I give you the problem and then you need to pause the video and try doing the problem yourself. You need to show your work because once you're done trying, I'm going to help you check your answer by actually just as soon as you unpause it, telling you what the answer is. But I don't put any work down. You need to be able to show your work. So I know that you're probably going to be thinking, okay, well, I just literally have to add two things together. There's not really much work. I really want you to remember that you are using this general formula. And so it is worthwhile to write that out and then substitute in what you know to show that you do understand the thought process behind just adding the two numbers, okay? So give this one a try. I'm going to give you 2¼ centimeters and 1.5 centimeters. Oh, by the way, when we're talking about linear measure and we give something 2¼ centimeters and 1.5, if it's not drawn to scale, that's okay. We just kind of keep going because the physical picture is not what matters as much. The math is what matters. All right, so pause this video. Bye. For your answer, you should have gotten that AC equals 3.75 centimeters. So you showed your work up here, even though it was stuff you could do in your head. There you go. Okay. If you didn't get that right, go back, try to figure out what you did wrong. Let's do example 2. Another example. So this is going to be when we know the whole. So when we know the total, essentially. So I'm going to have a segment, just like I've had for the other problems. But what's going to happen is I am going to know xz. It's going to be 17. And yz, I'm going to know is 3. So my task is going to be to figure out what xy is. And we're going to do it the same general way, but that's part of the reason that it's so important to be putting this original equation up there, even for things that seem straightforward like this, because we want to get in the habit of putting our original equation up there. So this one's going to be like xz equals xy plus yz. And the reason that we want to do that is because it's going to help us substitute things into the correct spot. So I see xz is 17, so that gets replaced with a 17. Xy, I don't have anything, so I'm keeping it xy, plus yz, which is 3. So now I'm just solving for xy. This is just like an algebraic problem, so I'm going to subtract 3 from both sides, and I get 14 equals xy. Once again, I have not drawn it to scale, but that's okay. So 14 equals xy. This one doesn't have units given, so I don't need to worry about giving units in my answer. And that's how you do it. All right. We'll practice these a lot more in class, but I'm going to move on to the second video. All right. See you soon.